Okay, number 8 says find a limit equal to the area shown. Well, here we go. We have area under the curve from 0 to pi over 2 of a sine 2x. So really, this is from 0 to pi over 2 of sine of 2x dx. So now I can just use my same old, same old. That's going to be the limit as n goes to infinity of the integral of, the sum of k equals 1 to n. Now let's see, so delta x would be pi over 2 minus 0, so it's pi over 2 times, divided by n, so pi over 2n. All right, a equals 0, so no problem there. We have, so a plus delta xk would be 0 plus pi over 2nk. So pi over 2nk is what I'm going to put into my function. So this would be sine of 2 times pi over 2nk. And then times delta x, which is pi over 2n. Okay, so we can simplify this to be the limit as n goes to infinity of k equals 1 to n of sine pi over nk times pi over 2n. There we go. All right, so let's move on to number 9. Okay, just back to asking to write an integral expression for this. So we know that delta x is equal to 2 over n, right? And it looks like there's no a here, so a equals 0, so b is equal to 2. So we know our integral is from 0 to 2. And 2 over nk would be our x term. And so it looks like we have x cubed plus 2 dx. Okay, that was number 9. Number 10, find an integral expression again for this function. So again, we have delta x is 2 over n, and this time we do have an a, it looks like right there, right? Because we're looking for this term and then it has something added. So remember, it's a plus delta xk. So there's the delta xk. So the a has to be 3. So a equals 3. So that means if b minus a has to be 2, so b minus 3 has to be 2, so b is equal to 5. So our integral goes from a, which is 3, to 5. Okay, and the function is a square root, and this is just your x term plus 1 dx. All right, let's do another one. All right, want an integral expression of this guy. All right, delta x is 2 over n. This time it looks like a is 2, so b has to be 4. So we're going from 2 to 4, and this is our x term, so it would be x squared plus 1 dx. Those are fast. All right. So number 12 wants us to write an integral expression. Delta x is equal to 2. This is our x term right here. So there's no a, so a equals 0, so b is 2. So we're going from 0 to 2 of x cubed plus 3. dx. If they're making you figure these out, if it was a multiple choice test, these endpoints would be what would be different, because you can look and see what the function is. It would be these endpoints that would be all different on the multiple choice. Let me just make sure we got that one right. We said it was x cubed plus 3, 0 to 2. Yeah, okay. Number 13. Okay, so we have, it wants a limit. So we have an actual interval from 2 to 6 of the square root of x dx. So delta x is equal to 4 over n. A is equal to 2. So our middle would be 2 plus 4 over nk. And that would be under the square root. So we would have the limit as n goes to infinity of the sum of k equals 1 to n of the square root of 2 plus 4 over n k, and that's it, times 4 over n. So nothing to simplify on that one.